Hi guys, here is section 8.1 on vectors. This was the first day, last Friday. So a vector is a quantity that has direction and magnitude. So by magnitude I mean a length or a size and direction. So a quantity that has magnitude or size and direction. So looking at this diagram here, the geometrical representation is right here. And looking at this, it's kind of like a directed line segment or array that you saw in geometry is what a lot of people said it looked like to them. So P, this part of it, so it has an arrow, meaning it's going in this direction. P is the initial point. And then we call Q, the place where our ray stops, is called the terminal point. And sometimes you'll hear it called, this is the tail end of it, and this is the tip of your vector. Vectors are denoted using this arrow symbol. It's kind of hard to see, but these are like half arrows like this. And then sometimes you'll see it with a full arrow on top like that. When you start getting into vector calculus, they don't really put these arrows on it each time. They just denote vectors by this bold case, lowercase letter, or bold face, lowercase letter, and that means vector. All right, so given a vector v with initial point x1, y1, and terminal point x2, y2, the magnitude of v, which we denote with these two lines like this, can be found using the distance formula. So from geometry, we know the distance formula is x2 minus x1, or a change in x's squared, plus y2 minus y1, or a change in y squared. Add those guys together and take the square root. So for a, b here, the magnitude would be the square root of -7 minus 8 squared plus -2 minus a minus becomes positive 4 squared. So -7 minus 8 is -15 squared. 4 minus 2 is 2 squared. That would be square root of 225. 2 squared is 4, or the square root of 229. If you can simplify it, you want to reduce it down, but I believe that's as far as we can take the square root of 229. All right, for RS, magnitude of RS, written like that, would be the square root of 5 minus a minus 3 becomes positive 3 squared, plus 6 minus 10 squared. That's the square root of 8 squared, plus -4 squared. This would be 64 plus 16, which is the square root of 80. And that simplifies down to 4 square root 5. So if I found anything out this week was that you guys do not know how to break down square roots. So remember, 80, we're going to come up with two numbers that multiply to 80. I know since it ends in 0, it's divisible by 10. So let's go with 10 and 8. 10 is 5 and 2. 8 is 2 and 4. 4 is 2 and 2. In order for them to come out of jail, is what I like to call it, in order for them to come out from underneath that radical sign, we're going to find groups of 2 because it is a square root. I have two groups of 2, so on the outside I've got 2 times 2, which is 4. On the inside, this guy is a lone little fellow. He does not have a partner in crime, so he can't break free from jail. And so my answer is 4 square root 5. All right, looking at number 3, magnitude for PQ would be the square root of 2 minus a minus 8 would be 10 squared. -9 minus 6 would be -15 squared. This is the square root of 100 plus 225, which is the square root of 325. Again, breaking this guy down, I know that 25 has to go in here. by times, let's see, there's 4 25s in each 100, so 4 times 3 would be 12 of them, plus 1 more 25 would be 13. And then 25 breaks down to 5 and 5. So 1 5 is going to come out of jail. Because he has a partner in crime, 13 is stuck in jail. All right. I don't think I put the other one on here, so let me scroll down just for your notes if you're still struggling with this. For number 4, you have this on your notes. The not absolute value, the magnitude of EF would be the square root of -6 minus a -1 squared plus -7 minus a -5 squared. This would be the square root of -5 squared plus -2 squared. That's going to be 25 plus 4 square root of 29. 29 is a prime number, so nothing can come out of that one. And we're almost done with the first page. The last part of the first page says zero vector. A zero vector is a vector that has magnitude 0. So you might be saying, well, how is that possible? What is a vector that has no link to it? Well, that would be just a point. And that's it for the first page of your notes for vectors. Coming up next, we'll talk about types of vectors and proving that vectors are equivalent.